And I'm going to create a new slide. Okay, so let's say, and I'm going to just start the show. Hey, okay. Let's say I had nope, that's not going to help me. So, oops, that's not what I wanted to do. Why is my taskbar coming up? Sorry, I'm obviously having technical difficulties, which is completely normal. For some reason my taskbar is blocking my instructions, so I can't change that. Okay, so that's... Well, actually, if we look at this molecule, we should be looking for things where we're attached to carbons, where we're attached to 4 different things, or atoms where we're attached to 4 different things. So I've highlighted one because it's really clear, but we have another one. So this guy down here is also a carbon attached to 4 different things. So let's start with this guy. Carbon 1, I'm going to call this carbon 2. No, I'm going to avoid 1s and 2s because we're going to use those for priorities. We're going to go all Roman on this. It's carbon I and carbon II. So let's take a look just at carbon I first. We've got, from here, let's try and assign priorities. Well, we know there's a hydrogen attached. So I'm just going to kind of sort of sketch it down like this. And that hydrogen is group number 4. This isn't actually a bad way to approach these kind of problems when you get them. You will get problems like this, I promise. So you've got that. Now we've got that carbon's now attached to 3 other carbons. Those are all carbons. You can't tell which one should get priority because they're all carbons. That doesn't help you. So what we look at is, what is that carbon attached to? What is the heaviest thing each of those carbons is attached to? So this carbon here, the heaviest thing it's attached to is a carbon. This carbon here, the heaviest thing it's attached to is a carbon. This carbon here, the heaviest thing it's attached to is a hydrogen. Hydrogen is lighter than carbon. So at this point, this guy falls out of the race. Okay. Now we have these 2 carbons. Now we're tied at this point. Because each of them is now, after that carbon thing that we just went through, they're both attached to 2 hydrogens, so that's a tie. So both those they're both CH2s attached to 2 carbons. And I can't assign priority based on that. So I need to walk down the chain. I need to go to, what is the next carbon on the chain? Or what's the next heaviest atom down there? And my options are, I can either walk onto either the hydrogens, which aren't very heavy, or I can walk onto the next carbon, which is heavier. So I go down the chain. So I go to this carbon now. And now instead of comparing these 2 carbons, I'm comparing this carbon and our carbon 2. And I ask myself again, what is the heaviest thing that carbon is attached to? And the heaviest thing carbon 2 is attached to is a bromine. Whereas the heaviest thing this carbon is attached to is another carbon. And bromine's heavier than carbon. So those are my priorities. I can then quickly look at where I've got my 4 already pointing back and away from me, so I'm good. I've got the smallest group pointing back, so I now have all the priorities. I have the things in the right orientation. So I draw my arrow, and I look at a clock, and I realize that that is counterclockwise, so that is S. Whereas if I look at carbon number 2, let's sketch that baby out. And we've got attached to 4 different things. We've already identified that. A good thing to go through all that first, right? And sort that out so you're not trying to do multiple things at once because that ends badly. I don't have a hydrogen attached to it. So I really like having hydrogens attached to things because it breaks ties nice and easy. But I don't have that. But I do clearly have a heaviest thing attached. That's the bromine. So the bromine's number 1. That's awesome. I note with fear that it's now pointing back and away from me, so it means I'm going to have to do a rotation. Then now I'm looking at the 3 carbons. Each of those are CH2 attached to another carbon. They're all tied. So I have to walk down the chain. I'm going to just change the color of my ink again. So I have to walk down the chain to these 3 carbons. Now this carbon over here is clearly a CH2 attached to another carbon. This carbon here is exactly the same. It's a CH2 attached to another carbon. This carbon is a CH, it's attached to 2 carbons. So once each of these guys kind of eliminates the next carbon as a tie, this guy has an extra carbon to pull on, so it's heavier. Because it's a carbon up against 2 hydrogens from the other 2 carbons. So in the cage match between these 3 remaining guys, this is the heaviest wrestler in the match. Then these 2 are completely tied. So I got to walk down to the next carbon along the chain because I can't break the tie on that carbon. We haven't used orange yet much. So now I'm looking at these 2 carbons. And this is where we can break the tie because this orange carbon is clearly attached to another carbon, whereas this orange carbon, we've run out of carbons. And the heaviest thing it's attached to is a hydrogen. So we can quickly assign the last 2. Okay, now we have to get this into a conformation that I can do this on. So I need to swap 1 and 4. I am going to do my ripping thing, swapping 1 and 4, like just because then I can get 4 back. Like that's the reason I'm doing that is because I want 4 back and away from me, which means I have that. I draw my line 1 through 3. It's R because it's clockwise, which means this must have been S. So this stereocenter is S, this stereocenter is S. So what I mean by breaking the tie when we have to walk down a carbon is when things are down a chain is when 2 atoms are the same weight, you need to go to the next atom on a chain. If those are the same weight, you need to go to the next atom on a chain. I don't know if that answers your question. I don't know if you're still here. No, she's left. Okay. Oh no, Claire's here. Yeah, okay, good. Awesome. There's going to be lots and lots of practice on this on the assignment I'm posting for the weekend, but the textbook also has lots of practice. No, it isn't overall RRS. RRS just defines that individual carbon. When we name the molecule, we include the R or the S in the naming. We're going to talk about it, I think, later on in the lecture that we just ended. You can skip ahead if you're really, really interested in this. But the overall molecule isn't RRS, just the individual atoms are RRS. Yeah, the video is going to be uploaded. It's going to be like bonus video. What molecule that has a carbon with 4 bonds? You mean a carbon that makes that attached to 4 carbons? Because all of our carbons are making 4 bonds. So like, it's got to be attached to something, no? I don't know. Iodine, fluorine, bromine, hydrogen. You're saying, what about naming that? Would it be like the molecule will be RRS? Yeah, no, the molecule is still not RRS. The atom is for RRS, but the molecule is not RRS. Yeah, I don't think it would be inappropriate to refer to this. So this is like, if you're going to name this, it's bromo, iodo. Nope, there's no punctuation or anything. These words all run together. Fluoro, except I should get fluoro before iodo. I'm really not good at the alphabet. I really have no natural talents I need to be a good organic chemist. Methane. I don't need to indicate that they're on carbon 1 because there is no other carbon. There is only one carbon. So this is bromofluoroiodomethane. It is one enantiomer of that. So that is 4. That is 1, 2, 3 based on weight. It's R. So that's R bromofluoroiodomethane. But I wouldn't say that this is an R molecule. I would say, hey, I've got some R bromofluoroiodomethane. Do you want some? And you would say, that sounds really dangerous and bad for the atmosphere. It's probably like, this would be a horrible greenhouse gas. But I wouldn't say it's an R molecule. I would say it's, I would measure whether it's dextrorotatory or level rotatory. I probably actually would and say it's plus or minus for the molecule as a whole. But if I'm naming the molecule, I would call it R bromofluoroiodomethane. But it's not like an R molecule. Yeah. Okay, cool. I will let you guys, those of you who are all done for the week, enjoy your Thanksgiving and your break. Yeah. See ya in a week and a bit.